Hello everyone, this is Carol Zhang. Welcome to the CGSP CCTV certification program. The topic of this video is Basic Theory of Video Management Software, VMS. Let us start with the learning objectives of this course. By the end of this course, you will firstly be familiar with the logical structure of VMS. Secondly, understand the typical business interaction and signaling process of VMS. Thirdly, know about the deployment structure of VMS. In order to achieve learning objectives, we will have these three parts in the course, including VMS logic structure, VMS typical business interaction process, and VMS deployment structure. The first part is about the VMS logic structure. As shown in this figure, we can learn about the logic structure of VMS from three aspects. For the software environment, VMS is based on the operating system. An information integration platform takes database system as fundamental data platform, and network as transmission media, and computer as terminal, and clock system for time synchronization. Based on these systems, VMS can provide various services, including video monitoring, video file storage management, video analysis, and such as motion detection, people counting, and alarm notification, system configuration, map management, and user permission, and device management and operation log. Modern video management systems use server-client architecture that constantly communicates, which leads to greater flexibility and scalability and simpler configuration. And client types include control client, which can provide abundant visualized applications, and a mobile client deployed on the phone so operators can monitor the videos at anywhere, and web client, which can realize quick configuration and application without installation. They cooperate to help administrator and operator complete the configuration and application of live view, playback, video analysis, alarm monitoring, map monitoring, and device settings. Then let us move on to the second chapter, VMS typical business interaction process for video operation and alarm. As we introduced before, VMS is used for central security management. Therefore, it is usually be applied in a control room, like shown in this picture. And there are many monitors here, and we usually call it smart wall, and security guards are the user of VMS in control room. Their main responsibility includes central monitoring of multiple channels and system health display and alarm handling. As we introduced before in the course of Introduction of VMS System, once alarm happened, related video displayed on smart wall to remind operators to handle. Thus, VMS is able to improve the business efficiency of security guards, lead to rapid alarm response and handling, and shorten the response time of emergency case. Now, let us talk about how video operation and alarm work in VMS. The video operation includes two applications, real-time live view and playback. Real-time live view is used to view real-time video of the connected cameras. Camera can connect with VMS server directly or via NVR. During viewing the real-time video, operator also can control PTZ camera, manually trigger recording, capture picture, and instant record video. In addition, playback is playing stored videos recorded by camera. Videos can be stored in NVR or storage server, and recording can be set for time period constantly or triggering events. After the configuration of recording schedule, users can use playback to view the history videos. The basic operation process is firstly, open VMS client and switch to video monitoring interface, and secondly, select camera to play video. Thirdly, drag time bar to search video for specific time, and finally close the video. The smart wall, or called as video wall, is commonly deployed in control room for video monitoring in medium and large application scenarios. It is composed of multiple splicing screens and display units and image controllers. It can display a full screen image and display different images on multiple screens. As this diagram shows, cameras and NVRs are connected with VMS server for real-time monitoring and video recording applications. In projects with smart wall, in addition to camera and NVR, a video decoder is also required to be connected with VMS server. Then, the live video and recorded video files both can be displayed on smart wall. Decoder can decode the image signal from the cameras. If the computer with client connects with joystick or PC keyboard, operator can efficiently control the smart wall and the image display. Therefore, the signal input for smart wall can be security camera video input and computer signal, and etc. Signal input is transmitted and distributed to project unit. Each unit displays a part of image, and all units compose the completely big image. Then we will focus on the data stream for video application. The orange arrows represent signaling, and the green arrows represent data. The first step is that operator selects the cameras for live view, recordings, or display on the smart wall on control client. Then, control client sends this signaling to VMS server. Then, VMS server transmits video signaling to video devices. If recording is required, VMS server sends recording signaling to storage device, such as NVR. And if displaying on smart wall is required, VMS server sends displaying signaling to the smart wall device. After cameras receive the signaling, cameras send real-time video data to control client, smart wall for viewing, or send to storage device for recording. According to the requirements, for NVR, recording data is sent to control client, smart wall for displaying recording video. And if operator wants to view the playback on control client or smart wall. The second application is alarm. We can set alarm for front-end device such as camera. Then, when there is an event occurs in the arming zone, for example, motion detection happens in jewelry store during nighttime, then the camera will capture and trigger alarm. Users will receive alarm notification on the control client. In alarm notification, operators also can check relevant capture pictures or recording videos. Then they can handle it rapidly. Firstly, operator configures event and alarm rule on device, includes source event, arming schedule, and alarm settings. Secondly, operator views alarm information from device in alarm prompt, such as alarm name and device name. And thirdly, views detailed information about the alarm, for example, captured picture and video. Finally, users can analyze the alarm information and take corresponding action. Then we can check the data stream for alarm. The first step is that operator can configure parameter for different types of alarm on client and ARM device. And then VMS server can send signaling and alarm settings to device, such as device or alarm input device. If the triggering device is alarm device, after the device receives the signaling according to the alarm settings, when device detects the alarm, it will take the linkage action, for example, take picture capture and push the alarm information to VMS. If the triggering device is external alarm input or output device connected with NVR, it firstly sends alarm notification to its connected device, and then send it to VMS server. If the triggering device is camera, based on the alarm settings, when camera detects the alarm, it will also push the alarm information to VMS. The final step is that VMS server transmits received alarm information to displaying device, such as smart wall. Then it shows alarm information to users. The final chapter is VMS deploying structure. VMS is applied in an enormous number of application scenarios, such as office building, retailing, banking, and city managing. For these various application scenarios, they have their own specific demands. Office building security concentrates on the video security. VMS with AI-empowered video security stands like a reassuring guard 24/7. And retailing industry faces more challenges, such as tight spaces with no security and loss prevention, operation optimization, and etc. Therefore, it requires not only video security but also intelligent data analysis for a well-designed store layout and better customer flow. Then, for bank, system reliability is of great importance, because any system issue may result in huge problems. In addition to video security, emergency response and access control can also be very important. Finally, for city managing, creating a secure and serene environment is essential for cities to develop and thrive. With increasing urban densities, cities need more advanced technologies to safeguard people and property. A VMS can provide a much more efficient way for keeping a sharp eye on things. There will be a continuously growing number of security devices connected to the system, so the network redundancy is crucial. For all these application scenarios, the project size can be varied from very small to large. According to the cameras number included in the system, the systems are identified as small project if there are less than 256 cameras, as a media project if the quantity is between 256 and 3,000, as a large project if the number of cameras is larger than 3,000. VMS composes of multiple function modules. In addition to core service program, each function module can select to deploy on an integration server or on different servers, according to the distribution of various components such as system databases, programs, and services. In centralized architecture, only a centralized server is connected with all devices, including NVR, switch, DOM camera, TVR camera, box camera, CVR clients, and TV wall and keyboard, and etc. The centralized server provides all functions such as database, program, service, alarm service, and file management. And this model has a simple system architecture and convenient resource management. However, for large-scale systems, the limitation of central management may be the unstable factor. In many industrial solutions, such as city security, train retailing, and etc., there are not only hundreds of cameras, and management is no longer centralized. VMS owns a multiple-level and multi-regional management model, so a multi-level distributed architecture is adopted. The management units in each region have their own management servers, and at the same time, the resources are aggregated to the upper level, and the upper level manages the resources of the lower level in a centralized manner. All VMS servers and their devices can be managed at the central server. The key point of this architecture is the synchronization mechanism of servers, data at all levels, to realize the interaction and the intercommunication of video between servers at all levels. VMS is the core of the system. Once the system is down, all or most of the functions of the system will be affected. Therefore, the data security and the stability of the system must be strengthened. Redundant architecture design can ensure uninterrupted operation of the system. Redundancy technology is suitable for some situations where system interruption is not allowed. Like shown in this diagram, server redundancy usually refers to the dual machine hot backup method based on habit and data synchronization, which realizes the active and standby mirroring environment composed of two VMS servers. Once the host fails, for example, if the server is down or the service stops abnormally, the system will start the service of the standby server to take over the business to ensure the continuous availability of the business. The switching process can be manual or automatic. The data of the two servers achieves data consistency through data mirroring or sharing data. Okay, that's all content for this course. In this course, we talk about the VMS logic structure, VMS typical business interaction process for video application and alarm, and VMS deployment structure such as centralized architecture, multi-level architecture, and VMS redundancy. Thank you for your listening and look forward for our next meeting.